Hi. So today we will learn uniform speed. If your vehicle is going with constant speed, suppose speed is 40 km per hour, and at every point the speed is same 40 km per hour. So what will you notice? You will notice that as the speed is same, the vehicle is traveling equal distances in equal time interval. If the speed is same, so you will be going same distance in equal interval of time, and that is how you can define uniform speed. If an object is moving equal distances in equal interval of time. Okay, let me delete this. In equal interval of time, then the speed is called uniform speed. Time, and however the small, whatever be the time interval may be, however small the time interval may be. Well, suppose you are going 8 meter in 2 seconds, then you will be going 4 meter in 1 second, then you will be going 2 meter in half second, then you will be going 1 meter in 1/4 of a second. So whatever be the time interval, smaller or bigger, you will be going equal distances in equal interval of time if you have uniform speed. Then the speed of, if an object is going equal distances, the speed is called uniform speed. Now, speed is a scalar quantity, so your uniform speed also is scalar quantity. Now you have one vector quantity similar to this, that is uniform velocity. Uniform velocity. Now everything same, equal distance traveling in equal interval of time along a straight path, and that is called your displacement. So make a little bit change in this definition of uniform speed and say equal displacements. So okay, if an object travels equal displacements, travels or goes, better you should write goes, equal displacements in equal interval of time then the velocity is called uniform velocity. Now, this uniform velocity can be defined in one more way. You should write that object goes equal displacement in equal interval of time, everything is same, and then you write along a given direction. Along a given direction. Okay, so this is how you will be defining uniform velocity. So uniform speed and uniform velocity. And what is uniform motion? Now an object which is having uniform speed. Okay, sorry. Let me say uniform velocity. So when an object is going with uniform velocity, then its motion is called uniform motion. When the velocity is uniform, then the motion of object is called uniform motion. Means equal distances travel in equal interval of time along a straight line, then such motion is called uniform motion. Okay, let me add one more thing. Along a straight line, along a straight path. Then the motion is called uniform motion. Now what is non-uniform motion? So if equal distances is not being covered in equal interval of time, then such motion you can call non-uniform motion. Equal distances are covered in unequal interval of times along a straight path. Along and vice versa, means either equal distances in unequal interval of time or unequal distances in equal interval of time along a straight path. Then the motion is called non-uniform motion. Now this non-uniform motion is totally undefined if the velocity is not changing by equal amount. So you cannot define where the object will be after some time unless you are told that, जब तक कि आपसे ये ना कहा जाए कि चलो ठीक है ये वेलोसिटी जो है यूनिफॉर्म रेट से बढ़ रही है या फिर यूनिफॉर्म रेट से घट रही है, तो आप इस नॉन यूनिफॉर्म मोशन को डिफाइन ही नहीं कर सकते. आप बता ही नहीं सकते कि आपकी गाड़ी की अगर वेलोसिटी यूनिफॉर्म नहीं है, बार बार चेंज कर रही है, तो आप इस टाइम में अब यहाँ से कितनी दूर पे गए हैं आप ये नहीं कह सकते. तो फिर कब आप इस चीज को डिफाइन कर सकते हैं जब ये चेंज ऑफ वेलोसिटी जो है यूनिफॉर्म है इन ठीक है, तो आप वैसे केस में इस वेलोसिटी को डिफाइन कर सकते हैं. सो नाउ व्हेन द चेंज इन वेलोसिटी इज यूनिफॉर्म, then you can still define the motion. You can still define the motion. Means you can say that okay, the velocity is increasing with this rate, then the vehicle will be at this position at this time. You could know if change in velocity is uniform, then you can say what is the position of object in a given time interval. So let me derive some equations pertaining to this situation also. Let the initial velocity is equal to u. Initially the velocity is u and velocity is changing, and it is changing with uniform rate. In equal interval of time it is increasing with equal amount. So finally the final velocity arrives, the final velocity is equal to v, and a distance s is traveled in this time t, and a distance s is traveled in this time t. Therefore, let us find a quantity called change in velocity. The change in velocity is equal to v minus u. Okay. So therefore change in velocity in unit time, change in velocity per unit time, okay, let me delete this, per unit time, that is v minus u by t, and this quantity has been given a name called acceleration. The quantity is called acceleration A. Therefore, A is equal to v minus u upon t. What is acceleration? The rate by which the velocity is changing. Acceleration is the rate by which the velocity is changing. You can also say that rate of change of velocity is acceleration. Rate of change of velocity is called acceleration. Now from this equation, A is equal to v minus u upon t. It implies that At is equal to v minus u. It implies that v is equal to u plus At, and this is called Newton's first equation of motion. This is called Newton's first equation of motion. So if velocity is not increasing and if velocity is decreasing, So rate of change of velocity will be negative, and that is called deceleration. Okay, so here if velocity is decreasing with uniform rate, then v minus u will be negative, and therefore acceleration will be negative. Therefore the equation becomes v is equal to u minus 80. When you combine the two, when you combine the equation 1 and 2, on combining, we obtained v is equal to u plus minus 80. So this is combined formula. Now negative acceleration is also called deceleration. Is equal to deceleration. Okay, let me delete this line. Okay. So therefore deceleration is equal to minus acceleration. So if deceleration is positive, acceleration will be negative. So this is your first equation of motion. Now second equation of motion. Let initial velocity u of a moving object is equal to u, where the change in velocity is changing with uniform rate. Velocity is changing with uniform then only you can do all these things, and final velocity is equal to v in time t and a distance s is traveled. Now you know that the velocity is changing with uniform rate. So average velocity will be v will be u plus v upon 2. This is one equation. Now we also know that average velocity means uniform velocity. Average is a constant number. So average velocity v is equal to distance per unit time. Therefore, putting the values, s per unit time is equal to u plus v by 2. Therefore, s is equal to u plus v by 2 into t. Now, second equation of motion, which is s is equal to ut plus half at square. In this equation, you can see you have u, you have t, but you have not v. So we will replace here v from first equation of motion. So now replacing v from first equation of motion. Therefore, S is equal to U plus, V is equal to U plus AT. Okay, so I replaced upon 2 into T, and it is equal to half into 2U T plus AT square, and therefore S comes equal to UT plus half AT square. Now, when the object is decelerating, means if speed of the object is reducing. If the speed or velocity, I should say velocity, because here you have used acceleration, and acceleration is there only when you have velocities and not speeds. So if the velocity is reducing with time, so acceleration is negative. And therefore S becomes equal to UT minus half AT square. Now let me equate this equation 3 and this equation 3 and, okay, let me take this equation 1 only. Equation 1 and 2. Combining equation 1 and 2, we get that S is equal to UT plus minus half AT square. So as per use you can take plus sign, as per use you can take minus sign. Now third equation of motion, and that is V square is equal to U square plus 2AS. So in the same formula, you will be doing up to this position, up to here. You will repeat all these things, and therefore you obtain that V is equal to U plus V by 2, and this is equal to S by T. Now, in third equation of motion, you see that you have to retain S, you have to retain U, you have to retain V, you have to from first equation of motion, you may know that V is equal to U plus AT, therefore T is equal to V minus U by upon A. So putting value of T in equation 3, we are on putting the value of T in equation 3, we get that U plus V upon 2 is equal to S divided by V minus U upon A. Therefore, S is equal to U plus V. Okay, let me change little bit it so that it take some form V plus U. U plus V can be written as V plus U divided by 2 into V minus U divided by A. And you know that A plus B into A minus B happens to be A square minus B square upon 2A, and here you have S. Therefore, V square minus U square is equal to 2AS, and therefore V square is equal to U square plus 2AS. This is Newton's third equation of motion. But if velocity is reducing then acceleration will be negative, and therefore your v square is equal to u square minus 2as, and when you combine the two, and you will get v square is equal to u square plus minus 2as. So these are the three equations of Newton's equations of motion. Therefore the three Newton's equations of motion. V is equal to u plus minus 80. Okay. Second one, S is equal to ut plus minus half 80 square. And third one, V square is equal to u square plus minus 2as. So here I conclude